In this lecture, let us discuss about information extraction. In our daily lives, we are relying heavily on search engines, right? Especially Google. So, have you ever thought about how these search engines understand the given query and extract the relevant results as if they know what we are thinking about? So, in order to provide the answer, first they should understand the language. So, how does the algorithm understand unstructured data and convert that into structured data and show the relevant results for us? So, let us take one example here. Say, if we enter two different queries on Google. So, in the first instance, or in the left side of the picture, you can see Google quickly identified the entity World Cup and the action is won. Whereas in the second query towards right side, even though if we didn't finish the sentence before finishing the sentence we got the result. So how do you think Google understood the context behind these queries, right? So we'll understand all these things. So how the core idea behind how these meaningful and relevant results are generated based on our search queries in this lecture. So, and also, what is the need of information extraction in our real life? So, as we already know, as we are dealing with a large amount of unstructured data, and with increase in unstructured data in recent years, we are facing a lot of issues, right? So, the tremendous amount of data comprises a massive amount of information, which can be overwhelming at times and even cause us to miss out important information. So, if we have huge amount of data, then sometimes we may miss out important information also. So, if this data is used correctly, it can lead to wide variety of beneficial outcomes. So for that, large volumes of data creates new challenges for information extraction techniques as unstructured data is growing at a furious pace. So this large volume of unstructured big data was too much for traditional information extraction algorithms to manage, right? So due to high volume and variety of data, these information extraction techniques needs to be upgraded. So if you consider information extraction, so we can define this as the task of extracting structured information from unstructured or semi-structured machine readable documents, or else we can say unstructured text. So when there are see here you can just see difference between unstructured text and structured information. So when there are significant, so you can just see in the here here you can see unstructured text, which is in the form of sentence. So if the information is extracted or if the information extraction algorithms are applied, then you can get structured information where we are going to identify important entities in the given sentence. So and how the entities are related to each other. So Barack Obama was born and he was born in Hawaii. So this is the example for structured information. So when there are significant number of customers, for example, then manually assessing customer feedback is very difficult task, and sometimes it may lead to errors also, and it's a time consuming process. So there's a good chance will overlook a dissatisfied customer. So by using sentiment analysis, we can improve, we can make the task easy, and also that task can be done within short span of time. So by doing sentiment analysis on all the incoming tickets and prioritizing them above the others, one can quickly identify most dissatisfied customers or the most important issues. At the same time, one might even allocate tickets to the appropriate individual or team to handle those issues. Because of this, customer satisfaction will improve dramatically. So, once we are able to identify the cases where the customer is dissatisfied, then we'll make to improve those particular cases. So, because of that, customer satisfaction will improve dramatically. Coming to the general pipeline of information extraction process, so we are having total 6 steps in order to extract structured information from unstructured text. First step is initial processing. Next, we have proper name identification, parsing, extraction of events and relations, anaphora resolution, output result generation. So this is the architecture where we'll take the raw text or the unstructured text and will perform sentence segmentation where the given paragraph is divided into multiple sentences. And on those sentences, will apply tokenizer or tokenization in order to get the tokens from the given sentence. So these tokenized sentences, on these sentences will apply POS tagging. So POS tags are assigned to each word or each token in the sentence. So these 3 things will perform in initial processing step. So here the first step is to break down the given text into phrases, segments and tokens. So you can do this by using tokenizer, segmenters, splitters, etc. So in initial processing, so here in initial processing stage, parts of speech tagging and phrasal unit identification, that is either the given phrase is a noun phrase or verb phrase, they are usually the next tasks. So coming to the second step, that is proper name identification. So one of the most important stages, we can say that this is one of the important phase in information extraction, because here we are going to identify we are going to identify classes of proper names, that is whether the name is, so we'll identify name of a person, location, organization, places, addresses and so on. So they may be found in practically any sort of text and are widely used in the extraction process. So even regular expressions are used to recognize these names. Coming to the third step, that is parsing. So here syntactic analysis of sentences in the text is done during this step. So after recognizing the entities, so important entities in the previous stage, those sentences, they are processed in order to find out various groups. So here we'll find out the noun groups which are surrounded by other groups. At the pattern matching step, noun and verb groupings are utilized in order to begin working on. And next step is extraction of events and relations. So this stage, it mainly finds out relationship between extracted ideas. Or we can say that, so this task can be done by developing various extraction rules which are used to describe patterns. So the text here, it is compared to certain pattern, and if a match is found, then the text element is labeled and that element will be retrieved later. Then we have coreference or anaphora resolution. This is mainly used to identify all the ways the entity is named throughout the text. So the step where noun phrases are decided if they relate to the same entity or not is called as coreference resolution. So if you take this example, here you can see we use this name Anna only once in the first sentence, but we are discussing only about that person throughout the paragraph in 3 different sentences. So the same Anna, it is referred as she in the second sentence, whereas her in the third sentence. So here, being human, we can understand that we are discussing about the same person throughout the paragraph. Whereas how a machine can understand that. So that is the important thing, right? At the same time, if you take this institute, so Anna is a graduate student at UT Dallas. So this is again an institute. So wherever we get this institute, then the system should understand that this institute refers to UT Dallas. So this task can be achieved by using co-reference resolution. So here, the step where noun phrases are decided if they relate to same entity or not. So that we call it as anaphora or co-reference resolution. And the final stage is output results generation. So here we concentrate on converting the structures which are collected during the previous 5 stages. So you need to convert those structures into output templates. So again, those templates should be according to the ones which are defined by the user. So it should be according to the format defined by the user. So it might comprise a variety of normalization process